Hi guys, today we're going to take a look at how you can use natural language processing with AI to create SQL queries and use those against a database. And this is a great way to enable people to search data without having to learn SQL queries. And there's a lot of nuance to this, so we're going to kind of unpack all the steps that you need to do to make this happen, but it's pretty straightforward in concept. So let's go and look at the architecture of this first. I'm going to show you kind of how it all works together. Then I'm going to look at some code. Then I'll show you an example that I wrote that's fairly straightforward. I'm going to talk about some of the best practices and caveats that you might want to consider when you're developing an application like this. So here is the application. It's pretty straightforward. So we're going to have a client. In my case, I'm going to be using a browser. It doesn't have to be a browser. It could be a mobile app. It could be a desktop app. It really doesn't matter. You're just going to interact with the client and allow the client to ask questions. And the questions will be in natural language. So you can ask it anything about the particular context you're dealing with. So if you're dealing with a specific database, you would want to ask questions about the data in that database. Like, what's the average price of an item in this catalog? Or how many days in this catalog had more than 150 visitors come to my website? Or something like that. There's any number of queries you could ask it that are in natural language. And so the client is then going to take that natural language and pass it over to a server. Now the server is really just a lot of glueware, and I wrote this in Python, and it's orchestrating a lot of the different parts. And the server will then receive the query, and it's in natural language at this point, and it's going to do something with that. It's going to take the question and it's going to add to it context. So this is important when you're doing this kind of work with LLMs. When you provide more context to the large language model, it gives the large language model more to go on. So it doesn't have to infer or guess as much. It can use the context as a way to create a crafted return back to the user that's going to be very specific to the ask that you're giving it. But all of this is done within the context of natural language. So you don't have to type in some kind of mysterious code into the prompt engineering, as I call it, into the prompt or the context that is computer code or anything like that. In fact, it's all very natural, like you were asking the question in the first place. So you're just telling it, what is the name of the database table? What is the structure of this table? Or maybe there's linking tables. What are the fields in that table? You're just telling it about the data that you're querying. And then once you have the original question plus that additional context, you pass that over to your large language model. In this case, I'm going to be using GPT-3.5 on Azure. And so when you pass that into GPT-3.5 on Azure, it's going to grab the question that you asked it and then also the additional context you provide, and it's going to try to analyze that and then create a SQL query and return that SQL query back to the server. And now it's just SQL, and the server can use that same SQL against a database. So in that case, it's just going to execute the SQL against a database. It can be any database. It doesn't have to be any one in particular, but I'm going to be using SQLite just as an example here. And then it returns the results as a table. And then you can turn around and turn those results into some kind of response and send that back to the calling client. So this flow is pretty straightforward, but the magic in this is really tied up in what you do in this additional context, what you pass to the large language model that will shape the output. And so you get back a decent query that will work against your database. So let's go look at the code and how that part in particular works for prompt engineering so that you can create a program that will do something very similar to this. But mine is pretty trivial, so I'm not going to say that it's the best example in the world, but it will get you quite a ways down the road if you look at how I did this. And I think the results are pretty good in my testing of this particular application. So here is the backend for this. This is the Python code that I wrote, and it's pretty straightforward. There's nothing really fancy about this. It's just a Flask endpoint, which is an embedded web server for Python apps, and it's using SQLite for the database. You don't have to use SQLite. I'm just using this one because it's a fairly easy to use database, and it works on a server without having to install some kind of database server. So for this example, it's just fine. And it's using the Open AI libraries from the pip package to call out to the Azure instance that I have already set up in Azure. And I'm just using that to plumb a lot of this stuff. So this is all the ceremony to get OpenAI configured, and this is just pointing me to the database. While we're here, let me look at this this database right here. This database is pretty straightforward. It's just called Jeopardy DB, and here's the structure right here. It's pretty straightforward. Let me do a query right here on this database. Let me refresh this, and then let's do generate a select query and run it. And this is the sample database, sample data, what we're looking at. So it's just a bunch of questions. And so it's got information about the show number, the air date, and the rounds, Jeopardy, double Jeopardy, the category was, and then the value, that's the bid, and then the question, and then the answer itself. So the actual data is pretty flat. It's just a basic database with a single table. So a few more marks here. The simpler you can make your data, the better off it will be, because this requires very little on the part of the LLM to actually have to think about joins and that kind of thing. If you're trying to do joins, that can be more complicated. So anything you can do to simplify the data, such as flattening it like this is, that will be conducive for better results. So in a more normalized state, you wouldn't probably have round as a string like this saying Jeopardy. You would put that into some kind of what we call some kind of dimension table, and then put a key into this. But the category would probably be something similar to that. You would have a category table and you would use a key for this dimension. But all that to say is you would end up with something that's flat, though. You want to keep it as flat as you can so that you end up with a better result. If you can put it all in one single table and denormalize it and just update that table through automation, that's actually a good practice to do for the data. But with the data in mind, let's go back to the code and take a look at that. With this database in mind. So that's the database. It's loading that database as the source, and it's just initializing the database. It's using some thread safe database access right here. That's all that's doing. And then this is where all the magic happens, is in this endpoint right here. And it's pretty straightforward. It's just receiving a post with a JSON object. It's got a single property called question. That's where you type in the question. And then it just echoes it back to the screen here, and then it goes out and gets the response. Now this is where I want to camp out for a minute. Let me turn on word wrap here so that we can see what's going on here. So this is the prompt that I'm sending as part of that additional context. So the question I'm allowing the user to enter, but I'm amending the question with additional context so that it's more than just the question. I'm telling the LLM exactly what I want it to look on with this question in mind. So I'm telling it, I want you to generate a SQL query from the following table called questions answers. And here's the columns from the SQL database, from a SQLi database. It's got show number, air date, round. Possible values include Jeopardy, double Jeopardy, and final Jeopardy. Category, value, question, and answer. And down here, I'm telling it a few other things. I say return just the SQL, include all the fields, and limit the results to 500. And so these three things are telling it to don't add any commentary to the query. All I care about is the query. Include all the fields. That's like essentially a select star. And then limit the results to 500 rather than doing a query that's going to return everything in the database. I just want to get the first 500 results back. And so with these parameters in mind, the language model should be able to take the question, and convert it into a SQL query. And so we take all that context in the question, pass it off to OpenAI. OpenAI then comes down here and returns the response. I get that response back as a SQL query right here. And then it calls the SQL database and executes a SQL query. And then it just iterates over the results, building back a return object, and returns the object back to the calling client. In this case, I'm using an HTML client, which is just served up a static content, and that's the formality to start the application. So this is pretty straightforward. Here's the client. It's just HTML5 code, nothing to it. You have a place to enter a question, and you hit the search box, and then it has a table to display results, and here's where it just calls out to the endpoint using fetch, and it's just fetching the data and getting the data back and then populating that table. So nothing real fancy there either. All that to say is it's fairly straightforward in its approach. So let's go over and run this and we'll see it in action. Okay, let's go ahead and start this up. I'm using WSL2 on Windows, so you could run this in a Windows context in Python too, but I like to use Python in a Linux context more. And I'm going to do Python 3 app py, and it's going to start the app. And should see the endpoint come up here in a second. And as soon as I get the debug active, I'm good to go. So let's reload the client. And here's what it looks like. Pretty straightforward. I'm just going to type in a question here. Let's type in something here. I want to see all of the questions that contain something about Star Trek. And let's see what this does. Search. And here are all the questions that, or at least the first 500, maybe this is all of them, that has something about Star Trek. And so you have quite a few here, and they vary in terms of difficulty. Some of these you may or may not know. Just depends on your knowledge about Star Trek. If I wanted some of the harder ones, I guess you could say where the round is double jeopardy, Geopardy, or something like that. And see if it gives me double jeopardy. See, I got all double jeopardy right here. I didn't even have to put that correctly. It just inferred that I was looking for a value of double jeopardy because I told it I wanted to see the category, the round rather, could be one of three values: jeopardy, double jeopardy, or final jeopardy. And you could sort by air date. You could do by show number. You could say, give me, and the value is greater than 800. And let's see what this does. So if it is able to interpolate that. So it's giving me questions that are 1200 in value, 2000 in value, and so on. So you can see that you have a lot of different questions there. And now I could change the topic here. Let's put in Star Wars and see what happens here. And getting lots of questions about Star Wars. So again, you can see how this is a very natural language question or statement rather, and it is passing that back to the LLM in the back end. So let's look at some of the streamed results that came back from this, just some of the JSON from the LLM right here. So this is basically what it's passing back. And it says, I want to see all the questions in Jeopardy where Star Trek, where the round is double jeopardy. And this is the select statement that it generated from that based on the context I provided and also the subject of the question, which is Star Trek. I was able to detect that. So it was basically saying select anything from questions and answers where round is double jeopardy and the question is like Star Trek and limit to 500. And that's because I only want the first 500. And it gives me some stats about the prompt usage, which is pretty decent. That's not too bad, 100 tokens or so. And you can see here's another one. This one used probably similar number of tokens. Yeah, pretty straightforward. And this was a little bit more complicated of a query, where questions like Star Trek and round is double jeopardy and value is greater than 800. So you can see the results, I think, are fairly decent with this particular application. So let's go and talk caveats with all this for a second. And I've already mentioned a few of those. So here's some of the things that you'll want to do with this, kind of to wrap this up. The first thing you'll want to do is, as we saw in the example data, is you want to basically optimize the data for searching. Now, optimized data for searching is data that requires few joins. You want to minimize the joins if you can between tables. So the more you can denormalize and flatten data, the better off it will be. Now, the way that I would typically do this if I was building an app is I wouldn't actually search on the live data. I wouldn't search on the normalized data. I would probably search on some presentation of that data. I would have some kind of data pipeline would take more of that that live data and transform it into something that is more search optimized, that's more optimized for the kinds of queries that I'm going to be doing. So that would just take all the join tables and then basically build a larger, flatter table from all those joins so that I can then easily search against that rather than trying to tell the LLM to build all these complex joins for me. And that will give me much better results. It simplifies the search domain and many other things like that. And it also makes your searches a lot faster. Another thing that you'll want to do is limit the amount of data you return. This is just a good SQL practice anyway. So you'll want to make sure you set a hard cap on whatever you're querying, because if the search question is too broad, you could end up returning a lot more data than you really need. So you probably want to put some kind of cap on it so that your user can't just say return all the data, and that would just select star without any filtering, and you end up with the entire data set on the screen, and then it would have a very difficult time rendering that, and it consumes a lot of CPU and bandwidth and all that. Just limit the amount of querying you can do with your particular application. Also, be very specific. I cannot overemphasize this. This is where all the magic happens. So be very specific in your context, like we said in my example. You tell the LLM exactly what you want. Now, you can't expect the user to do that. So that's what that system context that I was showing you did. I told it I wanted no more than 500. I want just the SQL. I want all the fields. I told it the table name, the field name, some possible values for those. I gave it a lot of things to work with. And by doing that, I get back very tailored results for my specific data. And it's able to also interpolate from the question the user enters based on that information. And so it's able to translate a natural language question into SQL with that additional context. So having that available is going to be the best thing you can do to make this work really, really, really well. Is just make your context better, refine it, run it through a lot of examples until you're satisfied with the results, and then do it some more. And then once you get your system context right, you'll have a much better result with the outcome, which will be a SQL query that you can run against your database. Just a few notes on this, though. This is not the most powerful way to search using LLMs. Again, this is a great way to search existing structured and semi-structured data. So like SQL databases that are already structured data, you have a lot of data in that database and you want a way to search it. This is just a way to do that. It just gives you a way to search something without having to learn SQL. You can enable users that aren't technical to search against large databases doing this particular method of search. And semi-structured data, this would be like a MongoDB or something like that, where you have things like JSON documents embedded in the database, and you can still search against that. So all of this is a decent tool for that, but the real benefit of using a vector search is whenever you're doing searches against unstructured data where the context is more what you're after rather than specific details about that context. So vector searches are great for documents that are like prose, like research papers, or fiction. Like I like to use my novels as an example of this. I've done an example of this in the past. But doing vector searches against vector databases when you're more interested in contextual details rather than specific details about data is where you'd want to use that. But this is going to be using using SQL. You're using keyword searches and things like that, which are a little less ambiguous, if you will, while vector is looking more for semantic meaning. So it's looking for ideas. So you're looking for things that are associated together rather than specific details like, I want to know how many questions contain the word Star Trek or that something like that. But in any case, just knowing when to use which one. And that's really the power of the LLM, because it can accommodate either one, but still you can use the LLMs just like we saw here, using the LLM to translate a question into a SQL query. So this is just another example. I like this approach for Some applications, of course, is not going to work for everything, but it's just another way to use AI. And this would be a very common use case for a lot of folks if they're wanting to integrate AI into an application and enable users to get meaningful data out of an application without having to learn SQL or having to write a complex query engine or something like that. Like and subscribe as always. If you have any questions about this code, you can drop me a comment in the comment section down below, and I'll gladly answer anything that you might have about this. Also, you can look in the video description to get a link to the repository, which I'll make available on GitHub, and you can use this code and explore it in your own dabblings in this particular context. So I'll upload the data as well, show you the data source and also the code assets as well, and that'll all be available so you can download and tinker with it in your own context. But as always, thanks for watching and look forward to seeing you on future videos.
If you like this content, please consider subscribing to the channel by clicking on the subscribe button. You can also like this content by clicking on the thumbs up or share this content with your friends, and also comment in the comment section down below. You can also find me online at www.blaze.net or on Twitter at @TheOneMule. And as always, thanks for watching.